Welcome back to the Health Longevity Secret Show, and I'm your host, Dr. Robert Lufkin. Rapamycin, Metformin, and Fisetin are all associated with improvements in markers associated with aging. We are now beginning to see them used by healthy individuals interested in promoting longevity. Daniel Tawfik is the founder, developer, and CEO of HealthSpan. HealthSpan optimizes human performance through interventions that target cellular senescence. HealthSpan was created to empower patients to regain control over the levers of aging that are at the foundation of most age-related diseases. Daniel holds a BS degree from UCLA in molecular, cellular, and developmental biology and physics. Daniel did his graduate research at UCLA's Protein Expression Technology Center, where he studied neurometabolic disorders. Before we start the episode, if you like what you hear, please consider supporting the work we do, as well as joining us on your personal health longevity journey. You can do both by becoming a member of our community. The benefits include a private messaging area, live QA sessions, weekly premiere videos, product discounts, free giveaways, and much more. You can join for as little as $1 per month, and the first month is free. See the link in the show notes for more information. And now, please enjoy this conversation with Daniel Tawfik. Hey, Daniel, welcome to the show.
Hi, Rob. How are you doing?
I'm so excited to have you on the program today and hear about the fascinating things you're doing with HealthSpan and these interesting longevity drugs. But maybe before we dive into that, could you take a moment and just share with us how you came to be interested in this area?
Yeah, there's multiple dimensions of curiosity, frankly, that brought me to wanting to understand the underlying mechanisms of aging. When I was an undergrad at UCLA, I took a biology of aging course, and we learned from an evolutionary biology perspective, we were looking at salmon, and after they reproduce, they just rapidly degrade, they die. And I was curious, I was like, well, that's just not wear and tear, right? We're kind of taught that we have wear and tear, we have DNA damage, and then ultimately tissue become dysfunctional. This is what aging has been. It seems like, based off of this example, it seems like there's some cell programming here. And I was curious to see what are the underlying mechanisms of this. When I was in college, I worked in a lab where we were looking kind of at metabolic pathways that progress age-related chronic diseases. We were looking at neurodegeneration specifically. And what I learned from that experience, and we're looking at kind of mitochondrial dysfunction in that context, is that human beings have much more power over health outcomes than the luck of the draw kind of paradigm we think about. So of course, there's genetic factors that play into health outcomes. But ultimately, it's very empowering to know that there are interventions, there's lifestyle changes we can make that can bend the curve in our favor. And so I love to geek out on the interventions that do that, right? So ultimately, the thing that made me want to make this kind of a career thing is my wife's health complications. So my wife, this is someone who was the captain of the water polo team. She's a super high achiever type, highly active. She had lymphoma, and she went through one bout of it, and 3 years of treatment, getting chemotherapy for lymphoma. She's she's in the clear for about 5 years, then it relapses, and then she has to do a stem cell transplant. And ultimately, I had taken kind of a break from the life sciences, where I was in software development, kind of entrepreneurial activities. I thought, well, I know all this stuff now about metabolic pathways, and in this specific case, cancer, how kind of there's a component of metabolic oncology that we can kind of use to bend the curve in our favor against getting cancer at some point in our lives. I think this is a good way to kind of sublimate if I could bring something to market that allows patients to optimize HealthSpan through these lifestyle interventions and pharmaceutical interventions, and help someone avoid the health outcome that my wife had, it would be a worthwhile pursuit. And ultimately, that was kind of the inspiration to kind of get off the sidelines and be kind of like a hobbyist, if you will, to make this kind of like the cause of my life. So it started with curiosity, kind of wanting to geek out on underlying mechanisms of aging. And then there's a very practical reason why we, put our time and attention into building a telemedicine practice around cellular senescence. So hopefully that gives you some idea of all the decision-making process on my end.
Yeah, I totally get the motivation there, and it's very admirable what you're doing, and it's a great area. The progress that's being made, the discoveries in this area, is changing so fast. So you're back to your concept of aging. I guess it's I get from that in your opinion, it's not really an accumulation of errors, but it's a programmed process. So what maybe you could just share with us a little bit, what are some of the mechanisms then of these programs? What can we do, and what's happening that controls this programming?
So there's multiple, with chronic diseases, there's just multiple, it's very complex, right? So you can kind of, you have to pick and choose what's your area of focus, right? And what I'm acutely focused on is cellular senescence. And to give the listeners some background on what cellular senescence is, a cell undergoes damage, UV radiation, some kind of DNA damage that makes it such that the body needs a way the organism as a whole needs a way to make it such that the cell doesn't proliferate, right? So we have cell programming to deal with damaged cells. So a cell can either go through apoptosis, which is like cell suicide. The cell has built-in programming, say, hey, there's damage here. Let's eradicate this cell before it incurs more damage. There's a second kind of evolutionary response to cell damage, which is senescence. And that's the arrest of proliferation of a cell. The cell still exists, but it can't replicate. It can stay in kind of like a zombie state, right? Where it can grow, it can exist, but it can't proliferate into what would be the third outcome and the worst outcome of cell damage, which is tumorigenesis, if the damaged cells actually replicate. So cellular senescence, the second outcome that I talked about, is a protective mechanism to guard against kind of the growth of bad tissue, if you will. But cellular senescent cells have a they have some defining kind of factors about them that make them something that as we age, when we accumulate more and more of them, they can cause a lot of tissue dysfunction. And that is, they can't proliferate, they can't replicate at all, but they can grow. They can, so there's three kind of traits of senescent cells. They exhibit hypergrowth, hypertrophy, so they can, when they're exposed to growth factor, unlike regular cells that can't replicate, they just enlarge. They exhibit hyperplasia, meaning they can release mitogenic factors that cause adjacent cells to grow disproportionately in a way that's not healthy for the tissue as a whole. And then lastly, they exhibit hyperfunctionality. They overexpress certain molecules. In this case, senescent cells have this defining characteristic of something we call the SAS, and that's the senescent associated secretory phenotype, which is kind of a witch's brew of kind of very harmful molecules. So these are things like inflammatory molecules that cause damage to adjacent cells, mitogenic molecules that cause proliferation of adjacent cells. And so these cells, they're growing, they're excessively active in producing molecules that are causing damage to the tissue as a whole, and they don't carry out their original function, right? So you get this tissue degradation over time. And if you look at across the board of age-related chronic diseases, you see senescence as a foundation, kind of theoretically as a foundation for everything. So if you look at osteoporosis, you see hyperactivity of osteoclasts reabsorbing bone. If you look at keratinocytes, the overexpression of keratin leading to wrinkles. We had someone come to HealthSpan the other day interested in taking these a class of drugs called mTOR inhibitors for male pattern baldness. The reason why is the overexpression of like androgens leading to hair loss. And then neurodegeneration is probably the easiest to explain. It's the overexpression of these immune molecules that cause a autoimmune issue in neuronal cells. So the overexpression of tau proteins lead to Alzheimer's. It's like a very glaring example of this. So senescence, as when we're young, we're able to get rid of senescent cells or dispose of senescent cells at a rate that matches the rate of accumulation. But as we get older, there's a critical mass effect of where the senescent cells accumulate at a rate that outpaces our ability to dispose of them. And so as we get older, you see tissue degradation and dysfunction across, the entire organism. And that, to me, is kind of a universal theory that I could kind of dig into and look into the interventions that kind of specifically target that. That says, hey, but let's put some more time into kind of thinking about how do we target senescence and kind of this kind of umbrella deleterious dysfunctional state.
Mm-hmm. Yeah. Before we dive too much into senescence, I backing up just a little bit. I often hear Leonard Hayflick's work in the 60s, I think it was, about famously the generational limit for cell division, the Hayflick limit and all, as a trigger for senescence and these things. But what you're saying is it also accumulated damage in a sense also?
So yeah, there's a kind of a normal course that leads to a senescent state, but in the exposure to damage, the cell can go in these three routes, right? But from an evolutionary perspective, we're really hyperprotective against that third tumor genesis state. So there's either apoptosis to like self-detonate the cell, this kind of suicide state, or there's just arresting the cell's capacity to replicate entirely, and that's senescence as a protective mechanism against tumor genesis. So no more proliferation. The problem with a senescent cell is it's still exposed to growth factor. So we see when it's exposed to growth factor, when TOR, which we'll talk about, is switched on to kind of get in these anabolic states to grow. It has the defining characteristics of hyper growth, hyper overexpression of molecules, and then causing adjacent cells to just overly proliferate to get kind of a tumor genesis state as well. So it's a protective mechanism in one sense when we have the cell damage, but as with many things in excess, it becomes the driver of cellular dysfunction and tissue dysfunction, which we can see as we get older, right? So our tissue not being able to do its original function.
Now, you mentioned the effects from the senescence, the SASP, and this other hyperfunctionality, hyperplasia, et cetera. Are there ways we can follow that in a patient? Are there easy markers we can use, like CRP for C-reactive protein or anything? Or what are the best senescence markers if we had to pick something to follow senescent activity in a patient?
I think these are kind of inflammatory. You would see the difference if you took a biopsy of a young person and an elderly person. It'd be fairly easy to detect which is which, because the biopsy of the older person would just have more signs of inflammation, right? So the SASP we can kind of measure through proxies of inflammatory markers, right? So we have a solution where with HealthSpan, what we produce is you'll speak to one of our doctors who's focused entirely on cellular senescence, and they'll send a panel based off of their discussion with you and kind of measuring these markers of inflammation. So it's ultimately something you'll talk through with your physician on.
Mm-hmm. So for senescence now, what are the main drugs? And I want to get into HealthSpan in a little bit, but just generally, what are the main drugs that you look for combating senescence, and what are their mechanisms of how they work?
Sure. So from a mechanistic perspective, it's helpful to understand TOR. So it's a target of rapamycin. So TOR is this switch within the cell that directs the cell to either kind of go, the best way to describe it would be, the easiest way to describe it would be an anabolic state, a growth state, versus a catabolic state, which is, hey, we need to stop growing, we need to conserve energy. Oftentimes in this catabolic state, we go through a process called autophagy, which we use cellular debris to utilize for energy. So if you have this accumulation of these this SASP or these toxic proteins, let's use that as an energy source, right? So TOR is this switch within the cell that is really, its stimuli or lack of stimuli is it's detecting states of nutrients within the cell. So it's primarily looking at the amount of amino acids available in the cell, and then through the rate, through kind of mediated through the mitochondria, ATP to AMP levels. So in a state where you're low on nutrients, say you were fasting all day, TOR is going to, in the simplest terms, TOR is going to get a signal saying, hey, we're low on energy right now. Let's not proliferate. Let's not grow. All right. Conversely, if we're getting a lot of stimuli that says, hey, there's a lot of amino acids, there's a lot of ATP right now, it's a good time to grow, right? Like, it's like, let's be bullish on growing right now. Then TOR will signal to the cell, like let's, it might be a good time to replicate. It might be a good time to grow. It might be a good time to express kind of these aggregate proteins that we talked about. So with that being said, there's a lot of implications to that. So one thing, before we go into the medications itself, the implications for metabolic pathways are significant, right? So on the standard American diet, if we're constantly overfeeding ourselves, if we're constantly exposing ourselves to carbohydrates and, like a very calorie-rich diet all the time, you're in an anabolic state all the time, and you're overexpressing TOR continually, and that has a lot of negative effects, right? So that's a lifestyle intervention that you need to think about of what ways can we turn TOR on in certain seasons of life, and what ways can we inhibit TOR to get into a catabolic state to do some kind of spring cleaning. So in terms of lifestyle interventions, fasting is a way to signal, to kind of play the nutrient deprivation state as a lever to stop the TOR anabolic state from being flipped on, right? And so fasting is a great way to understand how TOR inhibition works. When you're in a fasted state, the cell is basically producing less ATP, and ATP is kind of the currency of the cell to do work, essentially. And when we're low on nutrients, we produce more of the form of energy. It's not a triphosphate, so 3 phosphate groups, but a single phosphate group, which has, each phosphate group is kind of the energy source that allows the cell to do work. So when you're in a fasted state, you're producing more AMP kinase. You're producing more, the ratio AMP, the lower energy version of this energy currency, to ATP. There's more AMP. The TOR, through a signaling pathway, says, oh, there's a lot of AMP kinase here today. Let's turn off this proliferative hypergrowth state, right? So fasting, exercise is another example of this, right? These are the lifestyle interventions. So that leads us into the prescription molecules that you can take. So Metformin is a fasting mimetic, right? I'm going to say this just to illustrate a concept. It doesn't really do, I'm going to use the word clamp. I think of it as like Metformin is a clamp on the mitochondria. It's not a clamp on the mitochondria, but it reduces the output of ATP, and it signals it increases the output of AMP, which then mediates this inhibition of TOR, mTOR. And it does this for very practical purposes. When AMP levels are low, it there's a cascade of effects here. But one of the things it's going to do, from kind of a very practical perspective, it's going to translocate GLUT transport channels to get more glucose into the cell. Hey, we're deprived on energy. Let's get some more glucose into the cell, right? So metformin is a way that we can induce this catabolic state, this autophagy state, that kind of the spring cleaning state. So metformin mediates a cascade of effects from a metabolic. A metabolic perspective, it's going to lower the overall release of IGF-1, which is a growth factor that causes cell growth and cellular proliferation. And it's going to do this cellular deep cleaning through instigating autophagy. So metformin would be top of the list. It has an incredible safety profile. The reason why we know mechanistically anything about metformin is there's tons of observational research on metformin with people with an assortment of comorbidities, whether it's diabetes, cancer. Their health outcomes turn out to be better than, in some cases, than kind of healthy populations. Looking at this observational data, folks like Nir Barzilai, folks who really put a lot of time studying metformin, wanted to look at the mechanistic mode of action for metformin. Everything I just spoke about is kind of like speaks to how metformin works, but it was first seeing that the health outcomes of metformin patients were surprisingly good, even in unhealthy patients. So metformin is kind of the medication that targets senescence through kind of triggering this fasting mimetic state. The second medication that also kind of mitigates the deleterious effects against senescent cells is rapamycin. They both fall into this category of kind of a xenomorphic. They kind of they mitigate against those hyper functional kind of states that I was talking about. Metformin does this through nutrient sensing, kind of mimicking the nutrient sensing pathway via the mitochondria. Rapamycin directly inhibits a portion of TOR that controls this proliferative growth state as well. And that's the medication that in the longevity space has the most interest because of its direct binding. So TOR is the target of rapamycin. And the R is, of course, the rapamycin part. So rapamycin seems to kind of be the rapamycin and its analogs, the new versions that pharmaceutical companies are working on, seem to have the most interest. It's a kind of a novel approach to mitigating the deleterious effects of senescent cells. So there's those two drugs which are kind of most interest, and they're really trying to mitigate the kind of proliferation of senescent cells and the deleterious effects of senescent cells. There's another group of medications that it's a little kind of it's kind of Brave New World a little bit. It's Senolytics, which is compounds that kind of push the senescent cells into its apoptosis state, right? So it's basically triggering a senescent cell self detonation kind of programming. And so like dasatinib, which is actually a chemo medication. I've never taken dasatinib. I know Dr. Green prescribes it. Fisetin and quercetin as a combination are of interest in kind of the senolytic space to basically lead to the eradication of senescent cells. Rapamycin and metformin are kind of limiting the harmful effects of them and stopping the proliferation of senescence. Senolytics are targeted towards the eradication of the senescent cells.
I see. So yeah, a combination of both the rapamycin and the metformin to decrease senescence, and then the Fisetin to be actually a senolytic to destroy the cells that already are senescent in a sense there. So we have these drugs. Now I want to hear about HealthSpan, about your company that makes these medications available in a supervised medical setting for patients that are curious about that. Yeah, how did that get started? And tell me more about that.
Yeah, so it goes back to this experience I had with my wife, and kind of trying to figure out what to do with that kind of energy and frustration, and also the curiosity component. So prior to my wife's relapse, I was like fully, like, I was a geek on these different compounds and these lifestyle interventions. So I would, fast over the weekends. I would do a 24-hour fast every Saturday, and sometimes I would do a 3-day fast once a month. But I ultimately was very curious about taking metformin for myself, and I went to go talk to my primary care physician about taking metformin. And so we know that metformin is a drug that patients with diabetes take, right? And so I'm a healthy 35-year-old, and my PCP looks at me and says, like, why would you take metformin? There's no indication that you need to take metformin at all. And then I said, well, there's these studies and it was clear to me that one of the features of our medical system is that, physicians are bogged down with the day-to-day of dealing with putting out fires. Like, my brother's a physician, my wife's a physician. I'm surrounded by physicians in my life. All my friends from molecular biology days are physicians, right? And when I would talk to them about mTOR and metformin, their eyes would glaze over, like, oh, you're talking about this stuff again. And it was clear the pipeline from the research community to the clinical community, just there's a huge chasm because of kind of everything we talked about the constraints on doctors right now and all that they're responsible for in their practices. And so I thought to myself, okay, this is kind of an interesting idea. There's really not a clinical home for these folks like myself who are interested in cellular senescence, some might call kind of like biohacker types. There's not a place you can go to, or it's very hard at least to find a physician that's super knowledgeable about these things. And then there's this kind of like overlap with the wellness community too. So you might see like a functional medicine doctor, which is awesome, but there's also kind of like overlap with kind of holistic medicine that is less data kind of driven, and so you might, if you're kind of a biohacker type, you might see kind of a wellness person. So my thought at the time was like, I'd be interested to see if we can create a medical clinic that does a meta-analysis of kind of what's happening in the research community, but make it a specific focus, because I truly believe in this theory, this hyperfunctionality theory of aging, just targeting one thing, cellular senescence. And so I sat on the idea for quite a bit of time, because these are starting a company, as you know, it's like it's a lot of work, and it could be, it could be quite challenging. You're really kind of you're going to be dedicating a lot of time and energy into something. I sat on it. I was like, I'm not sure how many people there are in the world like me that want this thing. Ultimately, my wife's cancer relapsed, and we were at City of Hope Hospital, and I had been reading Peter Attia's article on metformin as kind of manipulating the quirkiness of cancer cells and their kind of ravenous consumption of glucose. And this is stuff that I knew back from my college days, but I was like, you know what, if this could help one person, if we launched this clinic, it could help one person, it would be a worthwhile endeavor. And so I said, okay, it was at her City of Hope hospital room that I was like, okay, let's do this. And that's when we put into play kind of developing the software and kind of mix and matching the vendors and all this stuff, and recruiting doctors who are interested in cellular senescence as a driver of aging, that said, hey, let's release HealthSpan.
And just to be clear, this service is for normal, healthy people. It's for people who want to look at longevity and anti-aging, and also you mentioned before the lifestyle things, like let's say I'm a patient, I'm already low carb, I'm in ketosis all the time, and I'm fast, I'm one meal a day, so I'm intermittent feeding. It can still benefit me above and beyond, even when I maximize my lifestyle things potentially. Is that not correct?
Yeah, so we're this type of patient, right? Like we're doing all the lifestyle intervention stuff, but we're intrigued by the benefit of some of these xenomorphic drugs. And so we're providing a home for folks like us who are kind of willing to kind of experiment. We're in a healthy state. We want to talk to a doctor. We want to take these medications under a doctor's supervision and kind of adhere to a protocol that we had talked about this prior to the podcast of putting together a protocol that's at least somewhat data driven, and we can talk into the challenges around some of these off-label repurposed drugs from putting protocols together. But it is a doctor supervised clinic where patients from all over the country can have a telemedicine consult with a physician in their state that can ultimately discuss lifestyle interventions, and if it's appropriate, prescribe some of these mTOR inhibitors to target the deleterious effects of senescent cells.
Okay, so for patients who want to come to HealthSpan, just to be clear, they can come. They don't have to physically come to Santa Monica, California. It can be done remotely through telemedicine. Is that correct?
Yeah, it's patients across the country. So right now we're just in the United States, and with the exclusion of Alaska, which has its own kind of telemedicine rules. So if you're a patient that is intrigued by some of these interventions, you can talk to a doctor, no matter from your own home, from your computer or your iPhone or your mobile device, and start kind of pursuing some of these senescent targeting protocols.
And the service for the patients, is this in addition, is this your service specifically manages the application of these drugs for longevity? It's not they would still go to their primary care doctor. So this would be in addition to that, right? So it's not a full primary care service. It's specifically for these drugs, correct?
That's exactly right. That's exactly that. Thank you for clarifying that too. Yeah, this is not, you're still going to go see your PCP when you have strep throat. This is for kind of the HealthSpan promoting kind of interventions. When you have an acute problem, you're going to go to your local doctor who will help you kind of put out that fire. This is for people that are specifically looking for HealthSpan promoting interventions.
And with that, I assume it's not covered by insurance because aging is not a disease according to the FDA.
Yeah, no, it's,
so yeah.
It's a huge problem in our field. It's I mean, so it's all cash pay, but this kind of opens up a conversation about, I talked about Rapalogs, these new medications that are being produced by pharmaceutical companies that essentially kind of mimic what Rapamycin is doing. And it's if you look at kind of the incentive structure of, so with Metformin, let me take a step back. Metformin and Rapamycin have existed for decades, right? And when we look at Rapamycin and Metformin conferring kind of a prophylactic benefit against these senescence-driven, age-related chronic diseases, there's no clinical trial that can be done against aging. There has to be a specific malady that the clinical trial is kind of targeting. So it becomes very challenging to kind of make the claim that Metformin has these HealthSpan promoting benefits. And when I say HealthSpan, I'm not talking about the name of our company. I'm talking about the amount of time in your life that you're in a kind of a good health state, right? You're not dealing with chronic disease, age-related chronic disease. It's just very hard to bill insurance for taking Metformin or Rapamycin. And so this is it's a cash pay service where it's kind of an elective thing for the folks who are coming to our clinic. I should say our patient base are super knowledgeable about these medications. They're probably more knowledgeable than any of us. They send us the papers on all the applications of it. They're very interesting people, but yeah, it's a kind of like, we have our tribe of folks that are very interested in senescence as a pathway of aging, and it's those folks that we're seeing in our practice.
Yeah, and just one mention too. You mentioned Barzilai, who's his one trial. I guess he's doing the TAME trial with Metformin. He's trying to advance it as a disease and get the FDA recognizing it and all, but it's a long process and very, very expensive. And like you say, there's very little incentive for drug companies to work with at least the primary rapamycin or metformin, which essentially are off patent now, and it's both good and bad, but it's a disincentive for them to move things forward there.
Absolutely. I think there's a lot of challenges we face as a community, and it's one of them is kind of the off-label repurposing of these medications that we have to figure out. Well, then if there's not an incentive to do real testing, how do we collectively test this stuff out? And maybe it is incentivizing it through the creation of these rapamycin kind of analogs. But I think collectively, the onus is on us to figure out how to prove safety profile and efficacy. And I think your work in the rapamycin registry does a lot to promote that. But yeah, this is kind of the pressures that we're faced with.
Yeah, tremendous challenges, but a lot of opportunities. Well, as an expert in this space, we always like to ask, what personal choices have you made in your lifestyle and the drugs or supplements you take to knowing what you know about longevity?
Yeah, so I would say for everyone, start off with lifestyle intervention. So like the easy, deal with the basics first, right? And so that is for me, I like one of the important pieces here is to understand the levers of aging, of these kind of the tools at your disposal to you can manipulate at different seasons of life, if you will. So what I will do is I know that I can kind of inhibit mTOR through fasting. I know that if I can restrict carbohydrates and in some cases amino acids like leucine uh, for periods of time, I can get into that autophagy state more regularly. Now, there's certain points in life where I want to be more anabolic, like if I'm weightlifting or like I do CrossFit regularly, and sometimes I want to be in a more anabolic state. I want to be in a pro-growth state, so I will stop taking metformin or fast, or I will, sufficiently provide nutrients, right? So then kind of leading in, I will take metformin on days that I don't work out. And then lastly, I take rapamycin once a week at 3 milligrams a week. It's a very conservative dosage, but those are the four primary things that I do in my life.
And Fisetin also, do you take that?
I'm not currently taking it. I was taking Fisetin and once a month at a heavy dose for like three days. I'll agree to protocol for it. I was doing it, but I haven't taken it in a while, and for no good reason. It just kind of fell off of my habit, kind of like routine.
Yeah, I think that the challenges that all of us face in the longevity space and for all the drugs you've mentioned are biomarkers for successful positive outcomes. We can always look for side effects, and there's certainly there's side effects with these drugs, but what is your approach or with HealthSpan? In other words, what do you monitor on the positive side, or is it just increase the dose till you get side effects and then pull back, or is it very...
To be completely honest, it's something we're still putting together, kind of the laboratory kind of protocol that we have. So we will send a phlebotomist to your home. This is part of the service, but we're putting together the panel right now. But we also kind of the problem that we have in this community is that we don't have a real good panel to measure autophagy. And so if there's any kind of researcher, working on wants to work on this project of like measuring autophagosomes, like that would be really interesting. Everything else we just have proxies for, and then we're also we're monitoring for side effects, hormone levels, etc. But we also, more on the metabolic side, we'll send you a continuous glucose monitor too, if that's something that you want.
Mm-hmm. Yeah. Oh, that's great. Well, how can people follow you on social media, Daniel? We'll have links down below in the show notes, but for people who are listening to this as an audio version, maybe you could just tell them the links that they can find you.
Okay, cool. So I'm active on Twitter. I think that's how we met. I'm at Dan Tawfik. That's TAWFIK. That's primarily my social. Most of my social activity is there. But you can go to my website. It's dantawfik.com. And if you're interested in kind of our clinical telemedicine practice, it's gethealthspan.com.
Great. Well, Thanks so much for spending an hour with us today. It was wonderful getting to know you, and also hearing about the exciting work you're doing at HealthSpan and the possibilities for dealing with senescence, with all these new amazing drugs you're using.
This has been a lot of fun, Dr. Lufkin. I really appreciate it.
Note, this is not intended to be a substitute for professional medical advice, diagnosis, or treatment. Always seek the advice of your physician or other qualified health provider with any questions you may have. Never disregard professional medical advice or delay in seeking of it because of something you have seen here. If you find this to be of value of you, please hit that like button and subscribe to support the work we do on this channel. Also, we take your suggestions and advice very seriously. Please let us know what you'd like to see on this channel. Thanks for watching, and we'll hope to see you next time.